All right, so picture this, an AI that can work on one single problem for weeks, maybe even months, and never forget what it learned on day one. Sounds pretty powerful, right? Well, we're going to explore a new technique today that could make that a reality. And it all starts with a problem that researchers are calling context rot. I mean, we've already seen AI agents do some pretty incredible stuff, right? They're writing code, they're helping scientists make new discoveries. But what happens when you ask an AI to do something really big? I'm talking about like rewriting an entire software application or tackling a research project that takes a whole year. Yeah, that's where things start to get a little tricky. You see, for all their power, these AI models have a critical, almost fatal flaw. The more you ask them to remember, the more they actually start to forget. It's kind of like trying to build a massive skyscraper on a foundation made of sand. It just doesn't hold up. And this weakness, it actually has a name: context rot. It's the super frustrating paradox where the more information you give an AI to try and help it remember, the worse it actually performs. It's kind of like reading a book where every time you turn to a new page, you completely forget the chapter you just finished. So you can see we're kind of at a crossroads here. If we want to build these truly intelligent, long-term AI agents, we have to solve this context crisis. Otherwise, we're just going to be stuck with AIs that are amazing at short sprints, but totally fail when it comes to running a marathon. Okay, so this isn't a brand new problem. Researchers have been trying to crack this for a while. One of the main ideas they've come up with is something called context folding, and it's basically what it sounds like, trying to shrink or fold up all that information so the AI doesn't have to remember so much at once.
And most of these methods, whether they're branching out to explore an idea or using a whole team of agents, they all pretty much rely on the same basic trick: summarization. They condense all that context down to save space. But what happens when you summarize anything? You lose details, right? And sometimes you end up losing the exact details you needed the most. Whoops.
So what if there's another way? Instead of forcing the AI to remember everything or to summarize and then forget, what if we could teach it to delegate? What if the AI could manage its own memory, just like a brilliant project manager? Now, that is a totally different way of thinking, and it's the core idea behind something called the Recursive Language Model, or RLM for short. We're moving away from that old summarize and forget model. Instead, the new model is delegate and synthesize. No information gets lost, it just gets handled by someone else. Pretty clever, right? Okay, so you're probably wondering, how does this actually work in practice? Well, the best way to wrap your head around RLM is to stop thinking of it as one single superbrain. Instead, think of it as a really, really smart manager. So this manager, our main AI, it gets its own workbench, basically a persistent digital space where it can work with data. Now, when a big task comes in, it doesn't try to do everything itself. No way. Instead, it hires a team of interns. These are just fresh copies of itself, called sub-LLMs, and it delegates all the specific little jobs to them. Hey, you, go do this web search. You, go analyze this piece of data. The manager just focuses on the big picture, while the interns do all the heavy lifting. And then at the end, it just collects all their reports and puts together the final answer. And the secret sauce here is a few key mechanics. First, the main model doesn't try to stuff huge files into its memory. It just accesses them through code when it needs them. It can also spin up a bunch of these sub-LLMs to work on different things all at once, in parallel. And this is the most important part. Only the interns, the sub-LLMs, are allowed to use the noisy tools, things like web search that bring back tons of messy text. This keeps the manager's memory, its main context, clean and focused. Okay, so this all sounds fantastic in theory, right? A manager AI with a team of interns. But does it actually work in the real world? Let's take a look at the data from the experiments. The researchers set up a pretty straightforward head-to-head comparison. They took a standard, powerful AI model as their baseline. Then they took that exact same model and gave it the RLM framework to use. And for good measure, they tested a third version, the RLM model, but this time they gave it a few strategic tips on how to tackle the problem. So on a really complex research task they called Deep Dive, the results were super interesting. On its own, the RLM model did, okay, about the same as the standard one. But when they gave it that simple strategy, basically, hey, remember to break the problem down and delegate, it totally blew the baseline out of the water. And that really shows that RLM isn't just a new tool, it's a new skill for the AI to learn. And this next part shows you exactly why it worked so well. When they looked at the token usage, that's just how they measure the AI's workload. The main manager model only handled about 15% of the work. A whopping 85% of the job was offloaded to its sub-LLM interns. It kept its own workspace completely clean and efficient just by delegating all that grunt work. But this chart is the real proof in the pudding. On a long context test, you can see the standard model's performance just absolutely falls off a cliff as the task gets longer. It literally just drowns in information. But the RLM, it just keeps chugging along, maintaining its performance no matter how long the task gets. It basically cured its own context. But here's a fascinating twist. It wasn't a win across the board. For math problems, the RLM actually performed worse. And the researchers have a pretty good theory why. They think that current models just aren't trained to use this kind of delegation for math. The extra complexity of managing the whole RLM framework just got in the way. It's like a manager trying to over-engineer a simple calculation that one person could have done in 10 seconds. So let's step back. What does all this mean for the future of AI? For its ability to remember and reason over really long stretches of time? Well, the first thing to understand is that RLM isn't some magic bullet that replaces the need for better core AI models. Think of it as a complementary skill. We really need both things. We need a smarter brain, a model with a more efficient way of paying attention. And we need this new skill, this context management, that teaches that brain how to use its memory effectively. And the researchers who wrote this paper put it perfectly. They believe the real breakthrough is going to happen when we start training models with this capability right from the very beginning. So instead of just tacking this on as an afterthought to an existing model, we'll be raising a whole new generation of AIs that just instinctively know how to delegate and manage their own thinking. And all of this leaves us with one final massive question. Forget about tasks that last a few hours. What could an AI agent really achieve if it could hold a coherent train of thought, not just for days, but for weeks, months, or even longer? What kind of huge scientific problems could it solve? What incredible, massive software projects could it build if it genuinely never forgot? That's the future that research like this is starting to unlock.